We are going to solve some previous year problem. So the first problem. Suppose we have a solution. So the problem 1. Suppose y of x equal to u of x into sin x plus v of x into cos x be a solution. Be a solution of the differential equation DE y double dash plus y equal to secant x. Okay, then what is u of x? Then u of x is, so the first option is log of modulus of cos x plus constant c. The second option is minus x plus c. The third option is x plus c. The fourth option is log of modulus of secant x plus c. So clearly already we know that if you know two solution of the homogeneous equation, if you consider the homogeneous equation, so the homogeneous equation is nothing but y double dash plus y equal to 0. So this is a homogeneous equation. So therefore the auxiliary equation is m square plus 1 equal to 0. Okay, therefore m equal to plus or minus I. Therefore the roots are complex roots. Therefore the complementary function is e power 0 times x anyway. So we have a some c1 times cos beta x, beta is 1, plus c2 times sin x. So anyway here y1 y2 is sin x and cos x. Therefore there are two solutions for the homogeneous equation. One solution is cos x and the other solution is sin x. Now the general solution of the given equation y double dash plus y equal to secant x, already we know the formula. So the general solution is usually we write y of x equal to some v1 of x into y1 of x plus v2 of x into y2 of x. So and then we simply write the solution is I think y2 minus y2 of x into integral y1 of x into the right hand side function r of x divided by the Wronskian of y1 y2 into dx plus y1 into integral y2 of x into the right hand side function r of x by Wronskian of y1 y2 into dx. I think this is the formula. Okay, now we have to find the Wronskian first. So what is the Wronskian of y1 y2? Is nothing but determinant of cos x sin x, and then derivative of cos x is minus sin x, and the derivative of sin is cos x. So what is the determinant of this? Cos square x minus minus plus sin square x. Therefore should be 1. So therefore the Wronskian is 1. And then what is the right hand side function is secant x. R of x is secant x. That is given in the problem. So now substitute everything in this equation. We have to write, therefore y of x equal to minus y2 is sin x integral y1 is cos x into what is r of x? Secant x nothing but 1 by cos x, but the Wronskian is 1 into dx plus what is y1? Cos x integral y2, what is y2? Sin x, and then r of x nothing but secant x, that is nothing but 1 by cos x into dx, because the Wronskian is 1. Now we can cancel cos x in the first term, we get just 1 integration dx is nothing but x, therefore this is nothing but minus x sin x plus cos x into is nothing but integral tan x, or simply we can sin x by cos x, integration of sin by cos, sin x by cos x dx. Therefore what is the integration of this? If you differentiate these, you will get the numerator. Okay, therefore should be but minus is missing because the derivative of cos is minus sign, but minus here missing. Anyway, no problem, you can put minus. So therefore should be log of the denominator. So therefore this is nothing but minus x sin x minus cos x. So the integration of this is nothing but log of modulus of the denominator cos x. Okay. Now if you want, you can add the constant c. Now what they are asking, if suppose y of x equal to u of x into this, they are asking what is u, the coefficient of sin x. So here finally we get what is the coefficient of sin x is minus x. Okay, so minus x, you can take this constant also, it's not issue. Therefore minus x is the answer. So therefore minus x plus c. This is the correct one. Okay. Okay. Now the next problem. Suppose what is an integrating factor? Yeah.
Sir, that formula you said, no, sir.
Yeah, that
y
is.
of, y
Yeah,
of
maybe
x
it's
is equal
this is minus, this is plus. In the formula.
No, sir. Where and all we can use that, sir? Like we used one formula to derive in this form.
Yeah.
Y of x is equal to v1 of x, y1 of x.
Yeah, we assume that if you know y1, y2 is a solution, the solution of the given non-homogeneous equation is we have to take v1 y1 of x, v2 y2 of x. If you simplify, you will get v1 v2. So I substitute here, we get this one. So actually maybe this is a v1 of x, and this is minus of this is v2 of x. Okay, just you come.
Your voice is breaking.
Oh, voice is breaking. Okay, it's now okay. So we know this formula, right? So I already yeah, so we know this formula, right? So I already mentioned this formula. So I think I don't know exactly, I think this is plus or this is minus, but anyway we have to look at into. So anyway, this is the idea. So you have to take this as a solution, and then otherwise just take this as a formula. So once you know this formula, just to you know y1 y2 and then Wronskian, substitute everything, you take the coefficient of sin x is the u of x, so you will get an answer. Okay. So just to go through the notes, I already write the formula, otherwise you have to derive the formula using that. So the second one is an integrating factor of IF, integrating factor of the differential equation dy by dx equal to 2x y square plus y by x minus 2y cube is first option 1 by y, second option 1 by y square, third option y, fourth option y square. So first you got to check the equation is exact or not, and then we got to find the integrating factor. So what is m? So m is nothing but the coefficient of dx. So anyway, we can rewrite the given equation, just cross multiply, we get 2x y square plus y into dx. You take that side, we get minus x minus 2y cube into dy equal to 0. So m is this one, m equal to 2x y square plus y, and n is minus of x minus 2y cube. Now we have to check this is exact equation or not. So therefore you have to partially differentiate with respect to y. So you will get 4xy plus 1, and we have to differentiate n partially with respect to x, you will get just minus 1. Therefore, these two are not equal. Therefore, it is not exact. It is not exact equation. So, if it is not exact, we have to find the integrating factor. So, there are two methods. So, first you got to find this dou m by dou n, dou x, dou y minus this whole divided by n. One by n into this, I think, right? So, that is a formula, or dou n by dou x. I think dou n, yeah, this is correct, dou n, dou m by dou y minus dou n by dou x whole divided by n. We have to check this is a function of x alone or function of y alone. Okay. Otherwise, you have to check, suppose it is not a function of x alone, we have to go the next step. What is 1 by m dou n by dou x minus dou m by dou y. Okay. Anyway, you will get just to find this one. Okay. So, first you start with just to find this value 1 by what is n minus of this thing. No, I think if it is first is m, then we have to take m. Okay. If it is first is n, we have to take n. So, m is, so m. So, therefore, what you will get in the denominator, we have 2xy square plus y, and then the subtraction is what you will get. So, if you subtract these, we get already minus plus, therefore, we have 4xy plus 2. Okay. So, anyway, we can take 2 from the numerator, we get a xy plus 1. In the denominator, we can take y outside, therefore, we get what you will get 2xy plus 1, right. So, sorry, in the numerator we have 2x because we take 2 outside in the first. There 2xy, 2x cancel, we get 2 by y. So, therefore, this is a function of y alone. Therefore, the integrating factor is e power minus this factor 2 by y dy. So, this is nothing but log y. So, e power minus log y. So, log y is minus log y is nothing but 1 by y. Log and e cancel, we have 1 by y. So, therefore, 1 by y is an integrating factor. So, no need to find this value. So, if it is this function of y alone, then this is integrating factor. Suppose this is not a function of y alone, then we have to find 1 by n into dou n by dou x minus dou m by dou y is a function of x alone, then e power minus integral f of x dx is the integrating factor. Now, in this case, 1 by y is an integrating factor. Okay. So, the next problem, already we solved that orthogonal trajectories, this problem. So, the third problem, suppose the orthogonal trajectories of the family of curve is given by y equal to c1 x cube, or so there are some options. Okay. So, the first option is I think we already solved this problem, 3y square equal to c2, and second option is 3x square plus y square equal to c2, and then third option is 3x square plus 2y square equal to c2, and then the fourth option is x square plus 3y square equal to c2. So, we will find this one. First, you got to differentiate the given given equation with respect to x. Therefore, the right hand side, left hand side, we have a dy by dx. So, c1 times 3x square. Okay, we have to cancel this c1. So, actually, what is c1 from the given equation? Y by x cube. If substitute here y by x cube into 3 into x square, we can cancel x square. Therefore, we have 3y by x. So, we have to take minus of the reverse. Therefore, we have to take what we have to take, we have to replace y dash by 1 minus y dash. So therefore minus of 1 by y dash equal to 3y by x. So if just cross multiply and then integrate, therefore we have a minus x by 3y equal to dy by dx. So if just cross multiply, we get plus minus x dx equal to 3 dy, so 3y dy. Therefore if we integrate, we have a 3y square by 2, and this x square by 2 we can take this side, we have x square equal to c2, some c2. So for 3y square plus x square c2, therefore the last one is the correct answer. Is the orthogonal trajectory of the given family of function. Okay. Now we look at the next problem. Okay. Fourth one. So for ABC in R, ABC are real number if the differential equation, what is the equation, ax square plus bxy plus y square into dx plus 2x square plus cxy plus y square into dy equal to 0 is exact. Then what is the values of ABC? So the first option, b equal to 2, c equal to 2a. The second option, b equal to 4, c equal to 2. The third option is b is 2, c is 4. And then the last option, b equal to 2, a equal to 2c. So first you have to check the equation is exact or not. So that is, what is m here? So m is nothing but ax square plus bxy plus y square, and n is 2x square plus cxy plus y square. Now you have to differentiate m partially with respect to y. So therefore dou m by dou y is just bx plus 2y, and dou n by dou x is 4x plus cy. Okay. Now just equal these two number. Therefore we have a bx plus 2y equal to 4x plus cy, because they said is exact. Now compare the coefficient. The coefficient of x, that side is 4, this side is b, therefore b equal to 4. Now the coefficient of y is 2 here c, therefore c is 2. Therefore b equal to 4, c equal to 2, the second one is the correct answer. Okay. And then the next one, the next problem 5. Suppose y1 y2 are two solution, y1 y2 are linearly independent solution of the differential equation. What is the differential equation? X square y double dash minus 2x y dash minus 4y equal to 0 for all x in the interval 1 to 10, closed interval 0, 1 comma 10. Now therefore we know the what is the Wronskian of y1 y2. Okay, so Wronskian of y1 comma y2 is y1 y2 dash minus y2 y1 dash. Okay, and it is given that the Wronskian of 1 is 1. Okay, that means okay, maybe I can say at the so simply say this is Wronskian of x. Okay, just notation, Wronskian of x. Suppose if the w of 1 is 1, it is given that at the point x equal to 1 the Wronskian is 1. Then what is the question is, what is the Wronskian of w of 3 minus w of 2 equal to? So the first option 1, so the options are 1 2 3 5, 1 2 3 5. Now this is actually Euler-Cauchy equation, right? So we know that what is the if you replace x equal to e power t, therefore t equal to log x, all the things. So finally it is reduces to d into d minus 1 minus 2 into d minus 4 equal to 0. Therefore d square minus d minus 3d, therefore we have minus 3d minus 4 equal to 0. So what is the auxiliary equation? M square minus 3m minus 4 equal to 0. Therefore what is the roots? The product of the roots is 4, the sum of the roots is 3. Therefore what is the roots? If you take I think maybe you will get 1 3, right? Okay, maybe okay 1 4, maybe m plus 1 into m. Okay, no, so maybe you will get a complex roots. So therefore what is the roots? If you find this formula, minus b plus or minus square root of b square minus 4ac by 2a. So therefore 3 plus or minus, this is actually 16 plus 16, therefore 25 is 5 by 2. So therefore 4, right? And then 1, right? I am right. So therefore 4 is a one root, and then minus 1 is another root. Okay, so therefore m equal to minus 1 comma 4 are the roots. Therefore what is the solution? One solution is y1 is e power minus t, and then y2 is e power 4t. Okay, so if you take we need a, so you are substituting x equal to e power t. Therefore what is t? Log x. Therefore we need everything in terms of x. So this is actually y1 of t, y2 of t. Therefore what is y1 of x? E power minus log x. So this is nothing but just 1 by x. And y2 of x is nothing but e power 4 log x. So this is nothing but x power 4. Okay, so now what is the Wronskian? W of x is equal to y1 y2 dash minus y2 y1 dash. So what is y1? If you take 1 by x, what is y2 dash? If you differentiate this, we get 4x cube minus y2, that is x power 4, into y1 dash. If you differentiate this 1 by x, we get to minus 1 by x square. So if we cancel this, we get 4x square, and then minus minus plus, we can cancel x square, we get x square. Therefore 5 times x square. I did any mistake there? Okay, the roots are 4 and 1. So what will get? I think substitute x equal to 1, you will not get 1, right? So maybe I think they directly maybe I think they take y1 equal to this, y2 equal to this. What happened in this case? Maybe w of t equal to if you fix e, differentiate this is nothing but 4 times e power t, e power 4t, minus fix this one, and then minus e power minus t. So therefore 4 e power 3t minus minus plus 5 e power 3t. Yeah, okay, anyway I am correct, right? Therefore 5 times e power 3t but therefore 5 times x cube. I get 5 times x cube, but here I get 5 times x square y, y1 y2 dash minus y2 y1 dash. Okay, so y1 is maybe I can take 1 by x, this 4x cube. Anyway, we can cancel. I did any mistake, so okay, quickly we can check. So therefore this can be written as m plus 1 into m minus 4, right? Because m square minus 4m plus 3m, therefore 3, okay, is correct. Therefore minus 1 4, yes, correct. So maybe they did some mistake. So this is w of x. Now what is w of 3 is, substitute 3 square is 9, 9 into 5 is 45, and then what is asking, w of 2, w2 4 20. So the subtraction is 15, but I don't know why this is happened. Okay, either the question may be wrong or I did any mistake. Yeah, so yeah, maybe okay. Okay, they take actually they take general case, maybe they take constant also, c1 times that function, c2 times that, then using the initial condition they will find the constant. Okay, maybe I quickly take, because if e power minus 4t solution, if you multiply any constant, that also a solution, right? So maybe I can erase this. So you take the scalar also, because the given condition we have to use w of 1 equal to 1. Okay, so that we can find the exact value. So therefore from this we can say what is y1 of x actually is 1 by x, but I take some constant c1 by x, and y2 is x power 4, but I am taking some c2 times x power 4. I take the constant also. Now find the Wronskian. W of x is the determinant c1 by x, c2 x power 4, the differentiation of this is nothing but c1 by x square, and derivative is nothing but 4 c2 x cube. So just to cross multiply, we have a 4 c1 c2 x square minus plus x square cancel, we have c1 c2 x square. Therefore we have 5 times c1 c2 x square. So this is w of x, and given that w of 1 equal to 1, so you substitute x equal to 1, we have 5 c1 c2, that is equal to 1. Okay, so therefore what you'll get, you'll get c1 into c2 should be 1 by 5. We know this condition. Now what is w of 3 minus w of 2? So this is w of x. Therefore if you substitute 3, we get 9 into 45. So 45 c1 c2 minus, if it substitute 2 4 20, so 20 c1 c2, therefore this is nothing but 25 c1 c2, but c1 c2's value is 1 by 5, therefore we can cancel 5, we get 5. So therefore answer is 5. So we use the initial condition, therefore you have to take that's constant c1 c2, because it's an initial value problem, it gives some initial value w of 1 equal to 1. So therefore you have to find the constant value c1 c2. Okay, this is the one problem. Now the next one, so we have to so we have to find the orthogonal trajectories. So I already said that orthogonal trajectory is nothing but if the product should be minus 1, C1 into C2, that should be minus 1. Okay, now question is, suppose for we have two family of curve. One is x square plus y alpha times y square, alpha times y square equal to 1, and another family is y equal to x square. Okay, so for what values of alpha these two family of curves are intersect orthogonally, that is orthogonal trajectories. So you have to differentiate these with respect to x. You get 2x plus 2 alpha y dy by dx equal to 0, and here if you differentiate we get dy by dx equal to 2x. Okay, now from this what is dy by dx is, if we take 2 cancel, we have minus x by alpha y, and here we have dy by dx is 2x. Now the product of these two should be minus 1, that is orthogonal trajectories. Okay, the dot product should be 1. Now what is the product of this? So therefore this family maybe we can call C1 and this is C2. C1 into C2 should be minus 1. Okay, so that is a definition of orthogonality. So therefore minus x by alpha times y into 2 times x should be 1, so should be minus 1. Therefore minus minus cancel, the numerator we have 2x square, if you multiply this one you get alpha times y. Therefore we get alpha equal to 2x square by y. Okay, but we know that the curve is y equal to x square, one curve. Therefore x square y are cancelled, we have 2. Therefore alpha equal to 2, then these two family of curves are orthogonally trajectories. Okay, but the product should be minus 1, that is the definition. Okay, now the next problem. Okay. We found that maybe okay, same problem, same type of problem they will ask. Suppose the differential equation is exact, then what is the value of alpha? Okay, so the 7th problem maybe we can write, suppose the differential equation 1 plus x square y square, sorry, x square y cube plus alpha x square y square into dx plus 2 plus x cube y square plus x cube y into dy equal to 0 is exact. Then what is alpha? So alpha equal to what? So the first option 1 by 2, 3 by 2, 2 and then 3. So just take m and then differentiate m with respect to y and then equal to the dou m by dou. So therefore what is m? The coefficient of dx is 1 plus x square y cube plus alpha x square y square, and what is n? 2 plus x cube y square plus x cube y. Now what is dou m by dou y is 3x square y square plus 2 alpha x square y, because we treat x is a constant. Now what is dou n by dou x? 3x square y square plus 3x square y. These two are equal because it's given that exact. Therefore we can cancel this 3x square. Therefore this 2 alpha should be 3. because already here x square y, this is x square y, therefore this 3 equal to 2 alpha, therefore alpha equal to 3 by 2. Therefore alpha equal to 3 by 2. Now similarly, suppose similar problem. What is an integrating factor? Integrating factor of the differential equation 2xy plus 3x square y plus 6y cube into dx plus x square plus 6y square dy equal to 0. So the first option is, what is the integrating factor? X cube y cube e power 3x e power 3y. Now anyway, definitely this will not be a exact equation. So therefore what is m? 2xy plus 3x square y plus 6y cube, and n is x square plus 6y square. Now what is dou m by dou y is 2x plus 3x square plus 18y square. Now what is dou n by dou x? 2x. Now what is the subtraction? So first you find dou m by dou y minus dou n by dou x into 1 by m. You have to find this is a function of x, y alone or not. So anyway we can keep 1 by m, and if you subtract this, we can cancel this 2x, we have a 3x square plus 18y square. But what is m? So if you write 2xy plus 3x square y plus 6y square y cube, the numerator we have a 3x square plus 18y square. So this is not a function of y alone, because some x terms are appear. Therefore we are not this is not correct. Now we have to look at dou n by dou x 1 by n times. So 1 by n times, or this is a homogeneous function or not. We have to look at this. So that is y into, we can, oh yeah, oh no, it's not homogeneous. Yeah, maybe no, it's not homogeneous. Now find what is 1 by n. Dou n by dou x minus dou m by dou y equal to 1 by, what is n? X square plus 6y square. Okay, and the subtraction is minus of 3 thing. So therefore minus of okay, anyway we can take 3 outside subtraction, because subtraction 2x cancel. Okay, this 2x cancel, so but is minus, therefore you can take minus of 3x square plus 18y square. We can take 3 outside, therefore we can cancel, therefore this is nothing but 3, right? Because the x square 6y square denominator also x square plus 3, therefore this is a function of x alone, because x power 0, therefore the integrating factor is e power minus integral this number, already we have minus 3 here, into dx, therefore just e power 3x. So this is the integrating factor. Okay, now next problem. So there are some problems to find the area. Okay, maybe do later that one. Okay, we solve some triple integral question. Okay, suppose V is a region bounded by V is a region bounded by the line x equal to 0, x equal to 2, y equal to 0, z equal to 0, and the line y plus z equal to 1. Then what is the value of triple integral over the region V? Y into dx dy dz is. So the first option is, so here function is, what is the function now? Y is the function, f of x comma y comma z is y actually. So the first option is 1 by 2, the second option is 4 by 3, the third option is 1, the fourth option is 1 by 3. Now is given that the range for x is 0 to 2. So first anyway the first integration should be variable, that first very beginning one. So this one should be variable. If suppose variable is the limit, then we have to pick that one. So therefore what is the range for x? So clearly a range for x is 0 to 2. Therefore we have to interchange the order of the integration. Therefore first the integration we can take x equal to 0 to 2 because it's given. Now next we take y value. So y varies from but z is 0. Okay, so here it is z is 0. Substitute z equal to 0 here, y should be 1. So the maximum y should be 1. Therefore y varies from 0 to 1. And z also varies from 0, but we don't know the upper limit, but from this we can consider 1 minus y. So therefore y, first we have to integrate dz and then dy and then dx. So this is the order. So therefore integral 0 to 2, integral 0 to 1, actually integration of y is nothing but just y dz, because y is constant, we have to integrate with respect to this. So you have to substitute 0 is the lower limit is 1, 0, upper limit is 1 minus y, and then dy dx. Now this is a substitute 1 minus y, therefore y into 1 minus y, therefore integral 0 to 2, integral 0 to 1, y into 1 minus y into dy dx. Now integrate with respect to y. Therefore y square minus y, therefore integral 0 to 2, if you integrate y square, y minus y square, therefore y square by 2 minus y square y cube by 3, 0 to 1 into dx. If you substitute the values, so 1 by 2 minus 1 by 3. So 1 by 2 minus 1 by 3 is 1 by 6, right? So therefore 1 by 6 outside we can take outside, and then you just integral 0 to 2 dx, that is x. So therefore just 2 to cancel, we have 1 by 3. So therefore answer is 1 by 3. So this is first you got to find the limit, and then we can do. Okay, now next problem. Suppose we have a differential equation y double dash plus 4 times y dash plus 4 times y equal to 0, and y of x is a solution. Okay, y of x is a solution of this equation. And what is the y of x satisfied? Y of 0 should be 4, and y dash of 0 should be 8. Then what is the solution y of x? So the first option 4 times e power 2x. So the second option 16x plus 4 times e power minus 2x. The third option is 4 times e power minus 2x plus 16 times x. The last option is 4 e power minus 2x plus 16x e power 2x. So first you got to find the auxiliary equation. Anyway, this is a homogeneous equation, no need to find the particular integral. So therefore the auxiliary equation is m square plus 4m plus 4 equal to 0. Therefore 2, because this we can simply write this is m plus 2 whole square equal to 0. Therefore the roots are m equal to minus 2 minus 2. Therefore roots are same and then real. Therefore the complementary function we call just y of x is some constant c1 times c1 plus c2 times x into e power minus 2x. So now it is given that y of 0 is 4. If substitute x equal to 0 should be 4. Therefore 4 equal to, if substitute x equal to 0, c2 term cancel because here x is there. But here if substitute x equal to 0, anything power 0 is 1. Therefore we get c1. So therefore we get c1 value is 4. Now differentiate this given solution. So this is a therefore what is y of x? So this is nothing but c1 plus c2 times x into e power minus 2x. Now what is y dash? Just you got to differentiate. This is you have to apply UV method. So first we got to fix the c1 c2 x and then differentiate e power minus 2x. Therefore minus 2 times e power minus 2x plus fix e power minus 2x and then differentiate this. So e power minus 2x fixed and then differentiate these, we get just a c2. Now given that y dash of 0 is 8, therefore implies the right hand side is, left hand side is 8. If substitute x equal to 0, this term is 0 and anything power 0 is, this term is 1, therefore minus 2c1. And here if substitute x equal to 0, this term is 1, just we get c2. And we know that c1 value is 4, therefore 4 into minus 2 is minus 8 plus c2 and this is 8, therefore c2 should be 16. Now substitute c1 c2 value in the given solution CF. Therefore y of x equal to c1 is 4 plus 16 times x times e power minus 2x. So that is the solution. So we'll look at the second one. Second one is the solution. Okay. Now similarly another problem, I think 9 or something, 9 or 10 something. Suppose we have a, if given that if y power alpha is an integrating factor of the differential equation 2xy dx minus 3x square minus y square into dy equal to 0. It is given that y power alpha is an integrating factor. Now what is the value of alpha? What is alpha value? So the first option is minus 4, third option is minus 1 and then 1. So first you got to find this m and then dou n by dou x. So m is 2xy and n is minus 3x square minus minus plus y square. Now what is dou m by dou y is just 2x and dou n by dou x is minus 6x. Now find either dou n by dou x or something. So 1 by n into dou n by dou x minus dou m by dou y. First you have to find this a function of x alone or not. This is 1 by minus 3x square y square plus y square times minus 6x minus 2x. You will get minus 8x by minus 3x square plus y square, but this is not a function of x alone, therefore this is not a correct choice. Now what is 1 by m? Dou m by dou y minus dou n by dou x. We find this one. What is the value? So this is equal to, what is m? 2xy. Now what is dou m by dou x? This is 2x and this is minus 6, therefore plus 6. Therefore 8x by 2xy. We can cancel this x, therefore cancel this, therefore we get 4 by y. Therefore this is a function of y alone. Therefore the integrating factor is e power minus integral 4 by y dy. So therefore e power minus 4, integration of 1 by y is log y. So therefore this is nothing but y power minus e power log y power minus 4. So this is nothing but log e cancel, we have minus y power minus 4, and this is nothing but is given that y power alpha. Therefore alpha should be minus 4. So alpha should be minus 4. Okay. Okay, the next problem. Maybe we can say we tried that one. Okay, so the next one, 11th problem or something. Suppose consider the differential equation dy by dx equal to ay minus by square, where a, b are positive number, a, b are positive, and is given that y of 0 should be some value we call y naught. Okay, so as given that, suppose as x goes to plus infinity, then what can you say about the solution? Then y of x tends to where? Y of x is solution. So the first option is 0, second option is a by b, third option is b by a, last option is y naught. So we have to find the solution, and then we have to find the solution. Once you find the solution, substitute x equal to infinity or x goes to infinity, we can see. So we can apply this by change of variables. Okay, so how we can do this? So if just cross multiply the given equation, so we have dy is given that dy by dx equal to ay minus by square. Okay, now just to cross multiply, we have dy by y terms, that is ay minus by square equal to dx. So again you can take y outside from this denominator, we have dy by y into a minus by equal to dx.
Sir,
Yeah, yes, tell me. Hello, yeah, tell me, you are not audible. Hello, what happened? So now the given differential equation can be written as, we have to separate the variables x, y. So we have to apply the partial fraction for this term 1 by y into this term. Okay, so if we apply the partial fraction to this, what is the term? We have 1 by y into a minus by. Okay, we can apply the partial fraction, we can write just to 1 by y plus b by a minus by. Okay, just to cross multiply by cancel, we have a by something, right? Therefore a is missing, therefore we have to divide 1 by a. Okay, therefore this is equal to this if you apply the partial fraction. Therefore this implies that 1 by a you can take outside, we have 1 by y into dy plus b by a minus by into dy equal to dx. Now integrate. So 1 by a is constant, integration of 1 by y is log y. If we integrate these, what will get? Again, log of b is constant 1 by this. Okay, so therefore we will get log of, because if we differentiate this, okay, no, so actually this is log of a minus by b by actually minus b. Okay, so this log of this. If we integrate this side, we have x plus the constant c. Okay, how we can integrate this one? So same thing. So we have to call this number is some u, and then we can rename it. Okay, so we call a minus by is some u. Okay, now what is differentiate? If we different, what is dy? Minus b dy equal to du. Therefore what will get? So therefore we have a b integral b a minus by dy. So everything you have to change in terms of u. Therefore 1 by u b du, b dy can be written as du, but minus is there. So therefore this is nothing but minus log u. Okay, so this is nothing but minus log of what is u? A minus by. So just a minus by. Okay, anyway, so actually this simply we can write this thing. Okay, anyway we can cancel this b, all the things. So simply, so if you change of variables, you will get the integration of this value is nothing but, okay, minus log of a minus by. Now this log a minus log b, therefore we have a log a by b. So finally we can simplify. So 1 by a times log of y by a minus by equal to x plus c. So you just cross multiply this a and then raise the exponential both sides. Therefore y by a minus by should be e power ax plus ac, or a times x plus c. Okay, got it or not? Just to cross multiply it. Now if you want a minus by y, just to reverse it, you will get e power minus a times x plus c. Okay, now as x goes to infinity, this e power minus infinity goes to 0. Okay, as s goes to infinity, this e power minus goes to 0. So therefore this term is goes to 0. Therefore the numerator should be goes to 0. A minus by should be goes to 0. So therefore from this we can conclude that y should be goes to what? A by b. Sorry, yeah, a by b. Yeah, if substitute y equal to a by b, then only we can get 0, right? Therefore y approach should be a by b. Okay, so therefore as s goes to infinity, so the solution goes to a by b. Okay, okay, maybe we can solve that problem. Suppose we have a system of equation. So suppose we are given two equation, so two differential equation, we have to find the solution. How to find the solution? So the problem is, suppose we have a one differential equation is dx by dt equal to x plus 2y, and other differential equation is dy by dt equal to 4x minus y plus e power 3t. So obtain the general solution. So we need a solution x equal to what, y equal to what. So x should be is a function of t, y is also function of t, because t is the independent variable, x and y are dependent variable here. So we have to solve the simultaneous equation. So how to solve this one? So we denote the operator d by dt is by d, capital D. Now therefore the first equation becomes, what you will get, dx equal to x plus 2y. The second equation becomes dy equal to 4x minus y plus e power 3t. Now take all the x terms are one side. Therefore the first equation becomes, you can take x outside, we have d minus 1 times x minus 2y equal to 0 from the first equation. From the second equation, if you take this side, we have minus 4x, and plus if you take y outside, we have a d plus 1 times y equal to e power 3t. Okay, got it? Now this is a equation in two variable x and y. We got to solve this. How to solve this one? Okay, maybe we can call the first, this is the first equation and this is second equation. We have to cancel or eliminate one variable and then solve other variable. So the better thing is maybe the multiply the second equation by d minus 1, first equation by 4x. So the first equation multiply by 4. So I try to eliminate x. If multiply by first equation by 4, we have a 4 times d minus 1 times x minus 4 into 2 is 8y equal to 0. Now the second equation we are going to multiply just d minus 1 operator. So what you will get? Minus 4 times d minus 1 x plus d minus 1 into d plus 1 is d square minus 1 into y equal to d minus 1 into e power 3t. Okay. Now just add these two equations. If we add, this first term is cancelled. So therefore this plus this, we have a d square minus 1 y minus 8y, the right hand side, left hand side. Therefore the right hand side just d minus 1 times e power 3t. Now if you simplify this, we have a d square y minus y minus 8y, therefore minus 9y is equal to, actually d is nothing but the differential operator with respect to t. Therefore if you multiply e power, maybe I can write one more step, d into e power 3t minus e power 3t. Therefore this is nothing but d square minus 9 times y equal to, what is the derivative of this? 3 into e power 3t minus e power 3t. Therefore totally we have 2 times e power 3t. Now we get a equation with a single thing. So d square minus 9 times y equal to 2 times e power 3t. So you have to find the auxiliary equation, you have to find the solution y in terms of t. So therefore what is the auxiliary equation here? M square minus 9 equal to 0. Therefore m equal to plus or minus 3. Therefore the complementary function is, the solutions are real and distinct, because this is nothing but m plus 3 into m minus 3. Therefore minus 3 and plus 3 are roots. Therefore c1 e power minus 3t, because this is an independent variable is t here, plus c2 times e power 3t. So this is CF. What is PI? Particular interval. 2 times e power 3t by the operator d square minus 9. So you have to substitute d equal to a. If substitute d equal to 3, we have a 0. Therefore what we have to do? We have to take x and then differentiate this. We have 2d into e power 3t. So that is the method, right? We have to differentiate. So 2 cancel, we have x 1 by d e power 3t. So it's nothing but differentiable operator. Therefore what is the 1 by d is nothing but integration. Therefore x into, what is the integration of this? E power 3t by 3. So this is a particular interval. Therefore the solution y of t is complementary function plus this one, that is c1 times e power minus 3t plus c2 times e power 3t plus x by 3 times e power 3t. Okay. Now this is y. So once you find the y value, substitute any of the equation. Either maybe you can substitute in equation number 1. Okay. So substitute y value in equation number 1. So what is the equation 1? The equation 1 implies d minus 1 into x minus 2y equal to 0. So this is the first equation. So therefore you just multiply inside we have a dx minus x. You can take 2. What is y? So y is nothing but c1 e power minus 3t plus c2 times e power 3t plus x by 3 e power 3t. Okay. Now actually this is nothing but again this is nothing but d minus 1 into x. So we can simply solve it. Okay. So the f of d is here d minus 1 operator. So therefore what is the solution? 1 is the solution. So otherwise we can otherwise we can directly integrate it, right? So otherwise what it actually if you rewrite is dx by dt minus x equal to 2c1 e power minus 3t plus 2c2 e power 3t plus 2 by 3x e power, okay, sorry, x, I think why I put x here, sorry, actually t, because t is the independent variable, right? So therefore this should be t, not x. Because in here independent variable is t. Okay. Now this is the first order differential equation. What is p? Capital P is minus 1. Q is the left hand side function 2c1 plus minus 3t plus 2c2 e power 3t plus 2 by 3 t times e power 3t. Now what is the solution? We know that. So what is the integrating factor? In this case e power integral p dx. So this is equal to integral, what is p? Minus 1, therefore minus dx is nothing but e power minus x. This is the integrating factor. Therefore what is the solution? X of t equal to x of t into integrating factor, because that is the solution. X of t into integrating factor equal to integral integrating factor into q into dx or dt. Okay, maybe is here yeah, dt, because independent variable is t. So now substitute the integrating factor and then we get x of t. Therefore x of t into e power minus x equal to integral, what is this e power minus x into what is q? 2c1 e power minus 3t plus 2c2 e power minus 3t plus 2 by 3 t e power 3t into dt plus c. So just you have to integrate, we will get answer. Anyway, this is the idea to find x and t. Now we find x of t. This is the solution x of t, and here we found that y of t. This is y of t. Okay. So given any system of first order differential equation like this, we have to find a solution x equal to, that is x of t and then y of t. That is a solution. So first what we have to do, we have to take the operator d by dt is capital D, and then the equation becomes like equation 2 unknowns. The unknowns are x and y. Just to simplify, usual solving the equation. So just to simplify, you get first you get either x or y. First, if you eliminate x, you will get y. So that is you go to solve the differential equation in y. So after you find the values of y, either you can take the second equation or the first equation. You substitute the values in that and then find the values of x. So there you get a differential equation in terms of x. So that's it. So this is method to solve the system of equation. Okay, now I can stop now. Remaining problems we will discuss in the next class. Okay, thank you.